Hello, Ms. Butler's class. We are in session 4, develop using area models and partial quotients to divide. Ms. Butler's not here today, so you're watching this on Schoology through YouTube, but stay on Schoology as you are learning about how to divide using area models and quotient products. So we are going to practice using estimation. We're going to divide by multi-digit whole numbers, by two-digit whole numbers, and explain the strategy that we use. So area model is going to be that main strategy that we've been practicing. Partial quotients kind of goes with our area model that we've been working on. We're going to start with our math warm-ups. So first we're going to start with multiples. And we'll start with the number 21. So think about the next multiple that's coming next for the after 21. So think of 21 plus 21, or you can say 21 times 2, right? Think for a second. All right, the next multiple is 42. All right, think again. What's the next multiple? 63. All right, think again. What's the next one? 84. So if you guys notice that there's a little pattern going on here, so we're going by 2, 4, 6, 8. While the other numbers are going 1, 2, 3, 4. So can you guys make a guess what the next one would be? All right, and 105. So next place value was, the next skip counting was to tens. And we went from 1, 2, 3, 4. Now we're at 5. All right. Now we're going to move on to our multiples of tens. And the reason that we practice these is because it helps us multiply much faster when we think in tens. All right. Count it with me. 3, 2, 1. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, now instead of just multiples of tens, we're going to try multiples of hundreds, okay, 100s. All right, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. All right, and these are pretty much as high as we need to go with our multiples of tens, and hundreds. We don't really need to go to thousands. And remember, the reason that we are practicing our multiples every day is because multiplication is really just the opposite of division. So if we use multiplication to help us divide, it will go a lot faster because multiplication kind of just makes a little bit more sense to our brains. All right, now we're going to focus on your which would you rather problem. So look at these problems and just think in your head, which one just kind of makes more sense to your brain? Which one's a lot easier to figure out, and come up with your own reasoning. You are not to share this out loud. You are to share this with yourself. And then Ms. Butler will come up with some reasonings why some of them work better than others. All right, so 150 divided by 15 could be a nice easy problem, because if we just think of this as 15 divided by 15, that is 1. And because there's a 0 at the end, we just add a 0. That's 10. All right, 990 divided by 10. We'll just use our 0 rules, cross those zeros out. Now it's 99 divided by 1, which is 99. Okay, simple. All right, and let's try this one. 620 divided by 20. Well, I can look at this as 62 divided by 2, which would be 31. And there's a 0 here and a 0 here, so the answer is 31. All right. Now, 200 divided by 25, that one is not as easy, so that one I probably would not pick out of any of those. I felt like D was not as easy either, because I had to do some work in my brain. I felt, honestly, that C was the easiest, But I can see how A can also be easy too, because you're just really doing 15 divided by 15. But we're going to go ahead and work out B. So when I think of B, I really think of quarters. So there's 4 quarters that make $1. So 25 times 4 equals 100. So plus another 25 times 4 would equal 100. So that means 4 and 4 is 8. So 25 times 8 equals 200. So the answer would be 8. So that one took me a little bit more work, but 25s are easy because you can think of money, but also you have to know how many quarters make $1. All right, well that is it for our which would you rather. We're going to go ahead and get started with our try it problem. And remember, your try it problems, you try it by yourself, don't ask for help, and don't show your answers to anyone. I know it's super exciting if you feel like you got the answer right, but remember, you are just trying the problem. We'll work it out together and you'll see the answer. All right, let's try it out. All right, so I'm going to read this question one time just to read it, and then I'll read the question a second time to find more information. All right, and then we'll read it a third time to make sure we understand what operation we're using. So first time just to read it, second time to get more information, and third time to figure out what operations I'm using. All right. An organic farm raises Leghorn chickens. The farm sells eggs by the dozen. There are 12 eggs in 1 dozen. The farm has 1,248 eggs. How many dozens of eggs are there? All right, first read, second read. Now we're looking for information. An organic farm raises Leghorn chickens. The farm sells eggs by the dozen. There are 12 eggs in 1 dozen. The farm has 1,248 eggs. How many dozens of eggs are there? Okay, so I'm going to use my orange marker to cross out information that I don't really need. Like, for example, an organic farm raises Leghorn chickens. It's nice to know that there's chickens on this farm, but it doesn't really help me answer the problem. So I'm going to cross it out. Try to use a black marker. Give me a second. All right, we are going to cross that out with the black marker. Okay, so the farm sells eggs by the dozen. It's kind of helpful, but I don't know if that's the most important part. All right, there are 12 eggs in 1 dozen. Well, if you didn't know that conversion, I think that one's very, very helpful. So I'm going to use my green marker because I want to remember that. So there's 12 eggs in 1 dozen. All right, and then the farm has 1,248 eggs. So we need to figure out how many dozens of eggs are there. So I kind of want to just draw this out so I can kind of understand the problem. So in my egg carton, right here, I have 12 eggs. Because this is my dozen. Okay? So I'm trying to figure out how many dozens is 1,248 eggs. So I'm trying to figure out how many dozens is that. Okay? And this is 1 dozen. So that's kind of what I'm trying to visualize. So my 2 numbers I do have are 12, and my other number is 1,248. Because 12 is my each, I know that 12 goes outside of my box. So because it goes outside my box, I will write the problem 1,248 divided by 12. Okay? I want you to try and solve this problem by yourself. I underline and shared information that you can underline as well, and I want you to try and make sense of this problem. Try it out and pause the video. When you are ready for the answer, you may unpause. All right. Thank you for working out this problem. I'm going to show you how to work it out and follow along with me just in case you might have gotten something wrong or if there's something you need to fix. All right. So our number is 1,248, and I need to figure out how many 12s can divide in there. But it's kind of hard because I don't really know my 12s too well. I'm going to write out my multiples. So I'm going to write 12 times 10, 12 times 20, 12 times 30, 12 times 40, and 12 times 50. Okay? And let's see which each one equals. So I know 12 times 1 will be 12, and I see 1 0, so that's 120. That's not quite 1,248. We got a long way to go. 12 times 20. Well, 12 times 2 is 24, and then I put a 0. We're still not close enough. 12 times 3 is 36, add my 0. 12 times 4 is 48, and I add my 0. And 12 times 5 is 60, and I add my 0. Well, I do know that 600 is half of 1,200. So I'm wondering if I should just double up 50 to make it 100, and we can get the number. Let's see. So 12 times 100 equals 1,200, which is very, very close to 1,248. So 12 times what equals 1,200? And the number you should put is 100. Okay? So now I got to figure out how much is left over. So I'm going to take that number, 1,248, and subtract 1,200. And I'm left with the number 48. So I went and did the math already. I just added a 0 here, but I know that 12 times 4 makes 48. So 12 times what equals 48? 12 times 4. So my answer should be 104. And since it asks a question, how many dozens of eggs are there? I will say there are 104 dozens of eggs. Period. And then we should always circle our answer, so I'm going to circle it right here so I know the answer. And I can underline it. There we go. All right, if you have any questions about how this works, you may ask yourself or just replay this video to see how we got these answers. All right, we're going to move on to the next question. All right, if you turn your page to model it, you'll see that they did partial product in order to divide. So they had the same ideas. They knew that 12 times 100 would make 1,200, so they put that there and then subtract. And then they were left with 48. So then they said, how many 12s divide into 48? And there was 4. So 4 times 12 made 48. And 48 minus 48 equals 0. So once you get 0, that's how you know you are done. All right, you do not have to use this method. It is okay to use the area model and the standard algorithm. Work with what you're comfortable with. But if this is a method you would like to try, you are more than welcome to. All right, and we're going to kind of just skip ahead to question 8. So again, try this problem by yourself. Don't tell your answers to anybody. And when you're ready to see the answers, just press play. For now, press pause and try the problem by yourself. All right, hi, welcome back. We are dividing 583 by 11. I went ahead and wrote out my multiples just because I'm running out of time on this video. So I'm going to go through this very quickly. I've drawn my area model, and now I'm going to answer my multiples. So 11 times 10 is 110. 220, because 11 times 2 is 22. This is 30